A friend once told me that if we had to lose one of our five senses, she would undoubtedly choose smell. Vision, hearing, and touch are so obviously important. Taste is nice and useful, but smell? Seriously? Well, one reason smell seems so useless is that humans do have horribly insensitive smell compared to, say, dogs. But the bigger use of smell is that it can save your life. For example, people burn carbon monoxide to cook food, though this gas is commonly known as, well, gas. However, this toxic gas is odorless and colorless. This makes it very dangerous when the gas leaks. So how can we alert people when it leaks? Although carbon monoxide has no smell, it is mixed with other substances called mercaptans to make it stink, so that when people sense the horrible smell, they know carbon monoxide has leaked. The horrible smell actually saves your life. How does smell work anyway? Well, you smell things when molecules from an object float into the air and end up in your nose. Every different type of molecule creates a different scent. And you, my dear friend, have conveniently learned chemistry. Maybe you haven't, just pretend you have. So you know all about molecules. Every different kind of molecule is a different substance, and we learned a lot of substances in chemistry. Let's list a few, shall we? Oxygen, a colorless, odorless gas. Nitrogen, a colorless, odorless gas. Carbon dioxide, a colorless, odorless gas. Do you see the problem? No? Come on. Basically, all the substances you learn in chemistry have no smell. So, where in the world do all those scents we smell come from then? To be sure, there are some substances we learn in chemistry that do contribute to our everyday smells. I can think of 4. Chlorine, a yellow-green gas that smells like, well, chlorine. It contributes to the smell of swimming pools, though not directly. It may be directly smelled from some tap water, some detergents and stuff like that, and in this case, a solution that's supposed to clean contact lens. Chlorine is also toxic. It was the first poisonous gas to be used in a war, but small amounts won't do much harm. Sulfur dioxide, a colorless gas that has a pungent, irritating smell, but don't take that too seriously because half the gases that have odors are described as pungent and irritating. But of course, sulfur dioxide is not pleasant, and you may have smelled it from matches or fireworks. And sulfur dioxide is toxic and it is a prevalent air pollutant. Ammonia, a colorless gas with a pungent smell. Where do you smell the substance? In your urine. The urea in urine can break down into ammonia, which contributes most to its smell. And ammonia is toxic, which is why you need to get it out of your body. Hydrogen sulfide, a colorless gas that smells like rotten eggs, except it would be more accurate to say it is the gas you're smelling when you're smelling rotten eggs. But since not many people regularly sniff rotten eggs, it may be more informing to say that hydrogen sulfide is the main thing that gives flatus its smell. If you don't know what flatus is, let's just say it's also called intestinal gas. And hydrogen sulfide is toxic. Yep, it binds with iron in the cytochromes of your mitochondria. The main damage is to your nervous system, but it also irritates your eyes, which are also part of your nervous system. But its main impact in the nervous system is to irritate your brain, because when Alexander explains its effects to you, you get really bored. So I'll stop now. So flatus is actually toxic. Say that to your friend next time they're polluting the air. Good idea? Maybe not. Hydrogen sulfide is also flammable, but please don't try burning it at home. Don't ask me why. Okay, fine, I haven't been very fair to our friend hydrogen sulfide, so I think I must clarify that there's only a very tiny bit of it in flatus. 1 part in 1,000 is enough for the smell to be overwhelming, but not harmful. And in fact, small amounts of hydrogen sulfide is actually needed for your body to function, but of course it is produced in your body, it doesn't need to be inhaled. Anyway, although we can't help but appreciate how good our textbooks are at finding toxic, foul-smelling gases to teach us about, it still doesn't explain where most of the scents we smell come from. I mean, imagine a world where the only smells there are that of swimming pools, matches, urine, and flatus. Pretty boring world. So where do all the other scents we smell come from? The answer is organics. The substances we focus on in chemistry are mostly inorganic because there are so many organic compounds it would take a lifetime to learn about them all. However, most smells are caused by organic substances. Take benzene. It's the main substance that gives gasoline its smell. Obviously, with its carbon and hydrogen atoms, it's organic. And it's also toxic. Or benzoyl acetate. This is the molecule that gives strawberries their smell, and it's organic. In fact, any substance with this benzene ring is called an aromatic compound because they so often, though not necessarily, have pleasant aromas. Other aromatic substances are responsible for the smells of cinnamon, vanilla, and ginger. Another group of atoms that makes molecules smell good is the ester group. Esters often give rise to pleasant, fruity odors, such as that of strawberries. Benzacetate is both aromatic and an ester. Chom-choms, fine bananas. Apples, pears, pineapples, and blueberries. There are even two smelly organic substances you do learn in chemistry, ethanol and ethanoic acid, which create the smells and taste of alcohol and vinegar respectively. That was just a small portion of all the smells out there, but since you can construct an organic molecule any way you want, it's easy to imagine they can give rise to all the different scents we smell. Just make sure you don't construct a molecule that's toxic.